Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing inequalities. This is standard A.3D in the great state of Texas, and we are using item number 47 of the 2019 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a college student with 2 jobs. Her combined work schedule consists no more than 48 hours in 1 week. Okay, no more than. It's going to be very important for us. So which graph best represents the solution set for all possible combinations of x, the number of hours she worked in her first job, and y, the number of hours she worked in her second job. So we don't have an inequality here that's given to us, but we need to create our own inequality. So combined, okay, that lets us know we're going to add. So there's just two variables right here, x and y. So when you combine her 2 different work schedules, it's no more than 48 hours in 1 week. That means no more than is going to be up to 48, but not more than, but we can include 48. So that's going to be a less than or equal to. So that's going to be the inequality that we're looking for. X plus y is less than or equal to 48 because that's going to get us up to 48 but not greater than. But we can include it, so that's what we need less than or equal to. Now that's, unfortunately, this is in our standard form. And not very helpful when we're graphing. We need to turn it into our slope-intercept form, which means it's pretty simple. We just need to go ahead and y is already by itself. We just need to go ahead and subtract our x from both sides. So it's going to end up being y is less than or equal to negative x, and then I've got this, still this plus 48. Okay, now we're cooking. We are in slope-intercept form. Even though it's less than or equal to, not an equal sign, we can now look at various things here. So we have our slope and our y-intercept evident to us. So remember, our slope is our m right there. Now, there is no coefficient in front of x, so when there's nothing there, we can always assume it's a 1, but it is a negative. So m is going to be a -1. Remember, that's your rise over run. So to make that into a fraction, we could say -1 over 1. So it goes down 1 and then over to the right 1. And as you'll notice, take a look, C and D, they actually have positive slopes, right? So this is a positive slope. It's moving up. That's also a positive slope moving up when you're going from left to right. We've got both A and B negative slope moving down. So we're good there. So I can eliminate C and D. Now, I've got my y-intercept right there of 48. That also lets you know why C and D are wrong. Look, their y-intercept is 0. Looks like A and B both have a y-intercept of 48, so that's not going to help me. So the only other thing that I could really look at is going to be this inequality, and that's actually going to be the deciding factor here. So when we're looking at inequalities, when you have a less than or equal to or greater than or equal to, we're looking at a solid line because we can include the numbers on that line, and both A and B are solid line. If you ever get a less than or a greater than without any equal to, it's going to be a dashed line because you cannot include any numbers on that line in the solution set. When we're dealing with shading, though, shading is a little bit different. When you're shading, when it's less than or equal to or less than, you are actually going to shade below the line. Less means below. And when you are looking at greater than or equal to or greater than, you're actually going to shade above the line because greater means above or more. I actually have a less than or equal to, which means I need to shade below the line. So my answer is A.